So I have two vectors I want to add together. The F1 vector is 25 newtons at 45 degrees, so it's going up and to the right. And then F2 is 50 newtons, twice as long really, and it's 120 degrees. And so I'm always measuring these angles with respect to the positive x-axis. So there's 120 right there. I'm using the tip-to-tail method to add F2 onto F1. You can see it's going up and to the left. Now the version of the vector equations I have over here is called the polar form because I have a magnitude at a particular direction. And then I can also write these forces over here in terms of, well, in a component form, where I have the x component and an I hat representing the x direction, and I have a j hat representing the y direction. And so there's my y component. So normally these are numbers here, but we'll write it symbolically as f sub x and f sub y. If I know the magnitude and direction of a vector, then I can find the components. As long as I have this theta measured always with respect to the positive x-axis, the x component will always be magnitude times the cosine of the direction. Making sure I have my calculator in degree mode when I do that, of course. And then I have the y being f times the sine of theta. On the other hand, if I know the components, f sub x and f sub y, then I can find the magnitude. Notice there's no vector sign here. I can find the magnitude simply by taking the square root of the sum of the squares. That's the Pythagorean theorem. And then if I need to find the direction up here and I know the components, I simply take the inverse tangent of f sub y over f sub x. Again, making sure my calculator is in degree mode. So if you want to find the numerical value of f1 plus f2, in other words, the net force or the resultant force, then I'll first need to convert from this polar form to the component form. So here is my f times the cosine of the angle, f times the sine of the angle. So here I've done the same thing for the f2 force here, like so. So there's my I hats, there's my j hats, and these are my x components, my y components. And so once you have it in that form, to find the resultant, you add up the x components, put it here. So there's the net force. By adding those together, I get this, a minus 7.32 newtons. And the reason it's minus is because the cosine of 120 is a minus. And we really shouldn't be too surprised that it's negative because the resultant vector really goes over and up. So it goes over to the left and up, and that over to the left indicates a negative x component. I added those up here and I got 61.0 newtons in the j hat direction. Now that I have the resultant, I can find the magnitude of the resultant. Notice I don't have a vector sign on it on top of this now. This means magnitude. I take the square root of this component squared and this component squared here. Notice that the I hat and j hat do not appear under the radical, of course, but I do keep my units, newtons, inside of the parentheses there, and remember to square those. And when I do that, I get 61.4 newtons. And then to find the direction, I take the inverse tangent of the y component, which is 61, over the x component, which is 7.32. And in my calculator, I get a negative 83.1 degrees. Now the reason why that is actually not the right answer is because this seems to indicate that our resultant vector goes off in this direction, when clearly we know that if you add this vector plus this one, it has to go up and to the left. And the reason that happens is because the inverse tangent will always give you an answer either in quadrant 1 or in quadrant 4. So it doesn't know how to get an angle off in this direction simply because it doesn't know if this minus sign is in the numerator or the denominator. So what we always have to do when we take the inverse tangent to find the direction of a vector is look at this diagram. And we see that since it's in the opposite direction, either we leave this number alone, or you add 180 or you add 360 to get it in the proper quadrant. Here we can clearly see that we need to add 180 to it. So that's what I've done here, taken the negative 83.1 degrees, added 180 degrees. So this is my correct answer here. And so my magnitude is 61.4. So now I've gone through the whole process of starting out with magnitude and directions for two forces, and I've added them up to get the net force with magnitude and direction here, making sure I put the vector sign on that force there.